All right, AQR students, we're looking at lesson, this is student activity sheet 10, concentrations of medicine. So, we're just going to do part A today. Have you ever taken a medication that your doctor warned you would not take effect for a few days? In this activity, you will investigate why that is the case. Consider the allergy medicine Sneeze Be Gone. The regular adult dose is 20 milligrams. As with all medicines, the body gradually filters Sneeze Be Gone out of the bloodstream. The rate at which the medicine is filtered out is called the flush rate. For Sneeze Be Gone, the flush rate is 30%. In other words, 24 hours after the pill is taken, 30% of Sneeze Be Gone has flushed out of the body. So number one, if 30% of Sneeze Be Gone has flushed out of the body after 24 hours, what percent of Sneeze Be Gone remains? All right, well, if we had 100%, we've lost 30%, then how much remains? 70%. So use your calculator's recursion feature to fill in the table below, assuming that an adult is taking 1 milligram dose per day, 120 milligram dose per day. So on day one, take 20. So let me get it going here, clear. So here's how we're going to use the calculator. I'm going to press 20, I'm going to press enter. That is my last answer I have is 20. So the next day, well, we'll show you this in just a sec. So on day, I know that in 24 hours, 30% of that will be gone. I will only have 70% remaining. So I'm going to say times 0.7 to represent that 70%. Plus, okay, plus we're going to add on another 20 milligrams, right? We're going to take another pill on the next day. And so at that point, we'll have 34 milligrams, which you can see is day 2. All right? Then I can just press enter because this will take the last answer times 70% because we're going to lose 30%, and then add another pill. And the next day we're up to 43.8. All right? So you can just keep pressing enter and adding in your data and do 20 days worth. All you have to do is hit enter a few times, like 17 more times or so, and put all your data in. On the assessment, I'll ask you one of these, maybe a couple of these at random. I might ask you for 6 and 16 or whatever, but I'll ask you for a couple days at random, okay? So figure out what each day you're getting here. Number 3, what value does the amount of Sneeze Be Gone in the bloodstream level off? So eventually, this is going to level off. It's going to hit a maximum. We'll see it getting close to a maximum. And how many days does it take for that to happen? And then number 4, what type of function can model the amount of Sneeze Be Gone in the bloodstream as a function of time? Explain your choice. So think about that. What kind of function? Is this going to be like linear? All right, does it go up by the same amount every day? Or is it exponential? Or is it something else? All right, think about how this is going to work. Okay? Number 5, what would you expect a graph of the amount of Sneeze Be Gone in the bloodstream as a function of time to look like? So think about, on day 1 we take 20 milligrams. So if I have here a graph, and down here I have days. So 1, 2, 3, 4. So I know, it's 20. Let's say it's 40. Let's say it's 60 here. I know at day 1 I started at 20, and the beginning of day 2 we had 43, is that what it was? 34. Day 2 we had 34, so it's up in here somewhere. Day 3 we had 43.8. Day 3 we're at 43.8. It's not quite a straight line here. But what's happening in between here? Is this going to be just connected by a line or a curve, or what's happening in between? Think about that. All right? Number 6 says, recall that the general form for exponential decay functions is y equals a times b to the x, where a represents the starting amount of the substance and b represents the rate of decay. For a 20 milligram dose and a 30% flush rate, what exponential function could describe the amount of Sneeze Be Gone in the bloodstream y as a function of time x? Do not forget that b represents the percent of Sneeze Be Gone that remains in the bloodstream. So b represents the percent that remains. All right, A is what you start with. Okay? So think about that. Number 7 says, since the patient did not begin taking the medicine until day 1, adjust your function rule by subtracting 1 from the exponent. Graph the function on your graphing calculator, sketch your graph, and describe your viewing window. So let's say we got here we're going to start, that first day we're going to start with 20, but I have a 0.7 rate, and then I had to the x power. But now I'm going to adjust my function by subtracting 1 from that, minus 1. Okay? So, graph the function on your graphing calculator, sketch your graph, describe your viewing window. So I'm going to come in here, clear out what I've got. I'm going to say 20 times 0.7 to the x minus 1 power. All right? And really, this is only good for one day, right? So from day 1 to day 2. Okay? And I'm just going to say 0.1 here. And I know that I'm going to put from 0 here for my minimum, and I'm going to put, let's put 45 for the max. Okay? And we'll go by 5s here. So, all right, this almost looks like a straight line. It is curving a bit, but that's only like 1 hour. If I looked at it in a longer period of time, for example, if I went from 2 to, let's say, 15, I think we'll see more of a curve to it. Okay? You can see it curves a lot more if I look at 15 days. But if I'm only looking at 1 day, I don't see a whole lot of change. All right? If I'm only looking at 1 day, start at 1 and go to 2, it almost looks like a straight line. All right? Okay. If time x is given in terms of the number of days, what happens? So let's, since our table over here went from 1 to 20, let's do that. Let's just put our window from 1 to 20. And we'll have that. All right. Okay. So if the time x is given in terms of the number of days, what happens to the amount of sneeze to be gone in the patient's bloodstream at the start of day 2 and the patient takes a second pill? How does this affect the graph? So at the end of day 1, we're at a certain point, right? So if I go to second trace number 1, if I put in x equals 2, notice I have 14 grams at that point because I've lost 30%. I've lost 6 milligrams from the previous day. I started with 20. By the start of the second day, I've lost 30% of that. Okay, we're down to 14 grams, but at that point, we're going to add 20, right? So how does this affect the graph? At that point, it should jump up to 43. Okay? So you use what you learned about step and piecewise functions in previous activities to restrict the domain of the graph and sketch your new graph. So, here I'm going to change my window. I'm going to say, well, I'm going to start. That's okay. So let's go over here, and I'm going to restrict my domain. I'm going to say, I'm going to use the division, open up a thing, and I'm going to say x is between 1 and 2. X is greater than or equal to 1, second math. We'll say greater than or equal to 1, second math right arrow, and x is second math less than 5 less than 2. Okay? And so there's day 1 right there. Just that little bitty little piece right there. All right? So now, they're going to take a second pill. Right? They take a second pill, and we have 34 times 0.7 to the x minus 1, because now they're starting that day with 34 milligrams. They ended the day before with 14, took a 20 milligram pill, so now we're up to 34, parentheses 0.7 to the x minus 1 again. And this time, divided by parentheses, I'm going to say x greater than or equal to 2, because this starts on day 2. second math, right arrow, and, oh, I forgot to put my X. And X, second math, is less than 5, less than 3. Okay? So there it goes up a little bit. So day 1, we take 20, it decreases, and then we take a pill, and it jumps up to 43 and starts decreasing until it gets to the end of the day. Okay? For day 3 and day 4 now. So at the beginning of day 3, we had 43.8. So for day 3, we're going to put in 43.8. This will be 0.7 to the x minus 1. And then this is going to be between 3 and 4. Parentheses, x is less than or equal to, I don't remember what I said now. What is it? 43.8. Oh, I'm sorry, I already have 43.8. X is less than or equal to 3, and X, second math, is less than 4. Close my parentheses. Oop, I did something wrong there. For 3.8.7, x is less than or equal to 3, and x should be greater than there. No, this should be greater than or equal to 3. Greater than or equal to 3, less than 4. That'll work. All right, so day 1. Here's day 2. There's day 3. I don't think that's right either. What's wrong here? 34 and then 43.8. No, that looks right. Huh. Something's wrong here. Times 0.7, 2 to 3, 1 to 2, 2 to 3, 3 to 4. Oh, I left off the x here. Dadgum. Well, no, I didn't. Greater than or equal to 3, and x is less than 4. Greater than or equal to 2, x is less than 3. Greater or equal 1, x is less than 2. So, second trace value, if I put in 3, why isn't that coming up? I think, enter the function, I think that we need to, I think this is not right. I think that this needs to be x minus 2, and this needs to be x minus 3. Let's see if that looks better. There's 1, 2, 3. I think that looks better. What is my window here? So yeah, I'm going to have to expand this. Let's say this is 60 now. 1, 2, yes, this looks better. Okay. Yes, that looks pretty good for the first 3 days. So day 1, day 2, day 3. Each day you can see the top point's going up and also the lowest point is going up. So as we go along, so I'm going to let you go from there. So you do need to adjust this. This should be x minus 2 here. On number 10, it should say 0.7 to the x minus 2. When we do day 3, we used y equals 43.8 times 0.7 to the x minus 3 to shift it over to the third day. All right, what do you expect for day 5? Right function, graph day 5. So I'm going to ask you, so do the first 5 days. Get the first 5 days in there and then take a picture of that, and that'll be the last thing you have to do for your assessment for today. Okay? So if we kept on graphing this thing, eventually it's going to kind of level out. This thing's curving, and it's going to level out. And you can kind of see that from the table you made back on the very first page. So the question is, see if you can answer this one, number 14. Assume the patient takes 20 milligrams every day. So what would be the minimum amount? What would be the maximum amount that they're hitting every day? So when they'll have their maximum first thing in the morning when they first take their pill, right, or whenever they take their pill. And then the minimum will be what they'll have right before they take their pill. So how could we figure out what those numbers are? All right? Okay. Hope you're doing well. Let me know if you have questions.